Welcome to this month's Mastertech program. Before we start, let's take a look at some of the news and information you'll find in this month's edition of Tech News. In the March issue, you'll find an article on the benefits of becoming an AES mentor, along with tech tips on service bulletins that cover current service issues. Don't miss the training tips and the service diagnostic software release listing for information you're sure to find useful. Be sure to pick up a copy of Tech News for all the details. Stay tuned for this month's program entitled Non-Destructive Paint Repair Update.
Over the life of a vehicle, there are a number of things that can undermine the paint's appearance or reduce its ability to protect the underlying body panel. The severity of the resulting condition is the determining factor as to which type of repair will be necessary. Welcome to this month's Mastertech Non-Destructive Paint Repair Update. In this month's program, we'll start off by taking a look at how current paint systems are applied. Then we'll cover the various causes of paint conditions, and we'll also show you how to diagnose the condition and repair the finish using the non-destructive method. Understanding the order of finishes and how they're applied to the vehicle is the first step. Let's take a look at the process. Current Chrysler Group paint systems consist of up to 4 layers. The thickness of each layer is measured in mils. 1 mil equals 1/1000th of an inch, or about the same thickness as this trash bag. The total vehicle finish, including all of the undercoats, will range in thickness from 4 to 9 mils and will vary by model and assembly plant. The first coat gets applied directly to the phosphated panel and is the epoxy primer, or E-coat. The primer is applied by submerging the bare metal body in a primer bath. Electric current then bonds the primer to the body. The thickness of the primer ranges from 0.8 mils to 1 mil. Next, the anti-chip coat is applied, which helps the vehicle finish resist chipping. This may be applied as a powder or a liquid. This coat will range in thickness from 2.5 to 3 mils. The base coat, or color coat, is next. This is the color of the vehicle. The thickness will range from 0.6 to 1 mil. Finally, the clear coat is applied as the last step. The clear coat may consist of 1 or 2 components and will add a luster and shine as well as protect the color coat. The clear coat will range in thickness from 1.8 to 2 mils. There is an exception to the rule. The Ram van and Ram wagon use a phosphate coating, then an E-coating, followed by a color coat that ranges from 1.7 to 2 mils. The Ram van and Ram wagon do not use a clear coat. As you have just seen, there is more to a vehicle's paint system than meets the eye. Now that we've shown you what makes up the paint system, let's take a look at some unwanted paint conditions you may encounter, beginning with those caused by environmental factors. Environmental causes of paint conditions occur as a result of a vehicle finish being exposed to contaminants in the atmosphere. These contaminants can be more or less severe depending on local and regional conditions. The acid rain condition appears as irregular patches of rough, discolored, or disintegrating surface spots. The spots range in size from minuscule to 3/4 of an inch. Acid rain spots result when vehicle and industrial emissions combine with moisture to form acids. The acids are deposited on the vehicle during precipitation, and when the precipitation evaporates, it causes the acids to concentrate in the residue. If the residue is not cleaned, acid rain spots form on the vehicle's finish. Even after the acids dry, they can be reactivated and worsen the condition if they become wet again. Alkaline spotting appears as irregular water spots with a dull finish. Severe alkaline spots have rough edges. Alkaline spotting happens as hard water on the finish evaporates, leaving an alkaline residue. If left in contact with the vehicle's surface, it will etch the paint. Bright sunlight will accelerate this process. Bird droppings appear in various sizes, shapes, and textures. Droppings left on the finish for extended periods of time will cause deep etching. The etching is due to the acidic chemicals in the droppings penetrating the surface of the finish. Bugs can cause spots of different sizes, shapes, and color depending on the insect. Spots can range from a blemish to etching down to the primer coat, often leaving the shape of the insect in the finish. Sunlight can dry the bug's remains, concentrating the acid or alkali. The condition worsens when the damaging chemicals remain in the finish for extended periods, or when improper cleaning methods remove paint along with the bug. Fuel spots appear as small droplet shapes and are caused by residue from diesel and jet engine exhaust and other high particulate emissions, along with stains from fuel fills. Industrial fallout, rail dust, and brake dust generally appear as a roughness on the surface of the finish, or small rings which appear rusty. These are more visible on light-colored vehicles. This condition is also apparent to the touch. Some of the causes are ferrous dust coming in contact with the finish, or steel particles which may be hot that become embedded into the finish. This condition can occur while the vehicles are being transported by rail, or if the vehicle is in close proximity to foundries, forging plants, and rail yards. Residue that has iron content will oxidize or rust on the vehicle finish. Tree sap removal is a sticky situation. The sap forms spots of various sizes which resemble pancake syrup. Because the tree sap often bonds to the vehicle finish, improper removal may cause the finish to come off with the sap, causing a worse condition. That covers our look at environmental causes of paint conditions. To keep these conditions at a minimum, here are a few ways you can help protect the vehicle's finish. The easiest and one of the most effective methods is to wash the vehicle often. For new vehicles stored on a lot, follow the recommendations in the Global Warranty Administration Policy and Procedures Manual. At least once a week, rinse the vehicle. Snow should be washed away more often since it can trap harmful contaminants. Dry horizontal surfaces. Polishing or waxing will go a long way toward protecting the vehicle by putting a protective barrier between the finish and the elements, along with adding luster and shine. Now that we've shown you some of the environmental causes of paint conditions, let's take a look at some of the physical causes. Physical causes of paint conditions are the result of errors in paint application or are conditions caused by contact with solid objects. Let's start with paint application related conditions. As the name implies, orange peel resembles the skin of an orange, with varying amounts of small uniform dents in the finish. This usually results from conditions during paint application, such as improper flow, improper air pressure, under-reduction of paint materials, excessive paint film, or the finish drying too quickly. Paint overspray appears as minute paint drops on the vehicle finish, which leaves a rough, dull texture. It is very evident to the touch. Overspray can be caused by such things as your neighbor spraying his fence too close to the vehicle, or industrial buildings being painted, causing mist from the spray guns to settle on the vehicle's unprotected finish. Overspray can also occur during repair on another part of the vehicle, or when vehicles are parked too close to those being repaired. Sags appear as runs or curtains in the finish and will vary in size and length. Sags are often caused by conditions such as low air pressure, over-reduction of paint materials, insufficient drying time between coats, or the spray equipment being positioned too close to the surface during material application. Our last paint application related condition deals with foreign materials, which appear as small irregular particles in the paint finish. Foreign materials may get into the paint surface due to a contaminated spray environment, inadequate air filtration in the spray booth, or the paint not being strained properly before application. Preventing paint contamination can be as simple as ensuring only clean equipment, including clothing, is used. Surface scratches and swirl marks appear as light scratches that may also be circular on the surface of the finish. This condition may be caused by contact from objects moving across the finish, improper compound or polish, or using excessive pressure or speed with a mechanical polisher. Whitening is when some areas of the finish appear milky or are discolored white. You may have also heard this condition referred to as fogging or clouding. This condition is usually caused by moisture being trapped under the clear coat. Whitening can be caused by aftermarket front-end covers, car covers, and magnetic signs left on for extended periods of time. It can also be caused by transit film, which has been left on past its expiration date. Now that we've covered most of the paint conditions you are likely to encounter, you'll need to know how to diagnose and repair them. Let's take a look. Before we get into actual tools and methods, it might help to define exactly what we mean by non-destructive paint repair and how repairs proceed from those that remove no finish to those that go beyond the non-destructive type. As a rule, non-destructive paint repair techniques deal only with the clear coat. Some of the repair procedures we'll cover in this program include washing and polishing using solvents and other items that will not remove more than 0.5 mils of the clear coat. Remember that a minor repair is one that does not involve refinishing. Any paint condition repair that removes more than 0.5 mils of clear coat is considered a major repair. Diagnosis of the paint condition requires finding out the depth or severity of the condition, which will determine whether non-destructive methods can be used or if refinishing is required. A diagnosis will also determine whether the condition is on the surface or if etching into the finish has occurred, which will identify the type of non-destructive method used. Some surface conditions can be repaired using procedures that do not remove any of the clear coat. Etching in the clear coat that is no deeper than 0.5 mils can be repaired using techniques that will not remove more than 0.5 mils of clear coat. These are also known as cutting repairs. Now that you have the guidelines needed to make the determination of the type of repair, you'll need to know what tools are available to help you get the job done and when to use them. The first tools we need to look at are used during inspection and repair to determine the effects of the condition and the repair process. One of the easiest ways to do a detailed inspection of a paint surface is with an illuminated microscope. Another of the most frequently used inspection tools is the electronic paint film thickness gauge, which measures the paint thickness on the vehicle in mils. A heat gun is used to correct a whitening condition, such as when the transit film coating is left on past the expiration date. For more detailed information on this issue, refer to Technical Service Bulletin number 232500. To make sure you're not getting the paint surface over 210 degrees, use the paint surface temperature thermometer. If you need to remove minor paint conditions, such as paint overspray, industrial fallout, or rail dust, a clay product, such as Meguiar's Overspray clay, works very well. To remove bugs, tar, or scuff marks, a product such as Mopar Super Clean or an equivalent will make the job easier. Just wipe it on with a clean cloth. Be sure to follow all safety and disposal procedures. To remove more difficult conditions or swirl marks, a mild compound or polish should be used. For example, one of the high-quality Meguiar's products now available through Mopar. A variable speed rotary buffer, which helps reduce application time and effort, is used for applying compounds, cleaners, and polishes. The rotary buffer will also produce a more professional result. Depending on which product you're using with the rotary buffer, you may need either a foam or wool pad. Depending on the job, you may also need Meguiar's Unigrit finishing paper. If you're just removing very fine scratches, 2,000 to 3,000 grit should be used to help minimize the amount of clear coat removed. A Meguiar's Unigrit sanding block will help you to achieve a more uniform finish in less time. As you have just seen, there are many tools that can make the job easier and faster with more professional results. Next, we'll show you how to make a visual determination of the paint condition. The first step in the process is to visually inspect the surface where the condition is present to determine its type and severity. Your sense of touch can also help in the evaluation. One way to enhance this is to cover your finger with cellophane. This will greatly increase your ability to detect conditions such as metallic fallout or overspray. Use an illuminated microscope to inspect the paint condition more closely and make the determination if it is on the surface or if etching has occurred. Remember that if any primer or bare metal is observed, refinishing will be required. Now that you know what to look for, you'll need to know how to repair it. Let's begin with repair procedures for surface conditions which do not remove any of the clear coat. You should start with repair techniques in an order that increases in aggressiveness. In other words, from least to most aggressive. One of the least aggressive methods is hand washing. Hand washing may remove some minor conditions from the paint surface, such as bird droppings or tree sap, if they haven't been left on the finish for an extended period of time. Use a quality product such as Mopar Car Wash. As mentioned earlier, a heat gun is used to correct paint whitening, sometimes known as fogging, which is another surface type condition. One of the most common causes of this condition is the transit film coating being left on the vehicle past the expiration date. Solvents like Mopar Super Clean can be used to remove bugs, tar, and tree sap. Just apply with a clean cloth and work it in to remove the condition. Always be sure to follow safety and disposal instructions. Next on the least to most aggressive scale is the overspray clay. This product is used to repair minor paint conditions such as paint overspray, industrial fallout, road grime, or tree sap. One of the best ways to repair rail dust contamination is with the overspray clay. Working the clay on the surface along with final inspection will remove the dust without removing the clear coat, leaving the finish smooth. If the condition is not repaired using the techniques you have just learned, you'll need to move on to a physical inspection and more aggressive repair procedures that may remove some of the clear coat. The physical inspection will determine the depth of the contamination or etching and will also determine whether to repair or refinish. Keep in mind that no more than 0.5 mils of clear coat should be removed to complete the repair. If the depth of the condition is greater than 0.5 mils, refinishing will be required. Prior to beginning any repair, check the depth of the finish with a paint film thickness gauge. Record your findings for future reference and make the determination of whether repair or refinishing will be required. If you determine the condition can be repaired rather than refinished, you'll need to proceed with more aggressive, non-destructive repair techniques. More aggressive repairs, also known as cutting repairs, still should not remove more than 0.5 mils of clear coat. These repairs are used when the previous procedures failed to repair the condition due to depth or heavy etching. As a general rule in these repairs, you need to follow the progression of least aggressive techniques in resolving the condition to most aggressive. Then back out to the least aggressive technique to complete the repair. Let's start our look with the procedure for contamination. If it hasn't already been done, start by washing the vehicle thoroughly using a high-quality product such as Mopar Car Wash or equivalent. Next, use the paint film thickness gauge and record the values for future reference. Polish the affected area using Meguiar's cleaner wax. If the condition is still present, use a rotary buffer with a polishing pad and Meguiar's swirl-free polish. Inspect and measure the depth of the finish with the paint film thickness gauge and compare the results with the original figures to ensure that you don't exceed the 0.5 mil threshold. If the condition still exists, buff with a foam cutting pad and a quality compound, such as Meguiar's Compound Power Cleaner or equivalent. Once again, inspect and measure the depth of the finish with the paint film thickness gauge and compare the results with the original figures so as not to exceed the 0.5 mil threshold. If the condition has been corrected, buff the area with swirl-free polish and then a cleaner wax. If the condition is still present and less than 0.5 mils of clear coat have been removed, you'll need to continue with a more aggressive procedure. The following procedures apply to paint conditions that did not respond to earlier methods, as well as to deep etching, sags, minor surface scratches, orange peel, and foreign material in the paint. If it hasn't already been done, wash the vehicle thoroughly. Next, inspect the condition in order to determine the most severe area of the vehicle. Mask off a 1 square foot test section to isolate the area and keep the rest of the vehicle clean. Measure the thickness of the finish with the paint film thickness gauge and record the values for future reference. Wet sand the area using a sanding block along with 2,000 to 3,000 grit Unigrit finishing paper and soap solution. Remember to use a consistent back and forth motion until the condition is removed. As with any wet sandpaper, let it soak 1/2 hour before use. Check the depth of the finish with the paint film thickness gauge and compare it with the original figures. If more than 0.5 mils of clear coat have been removed, refinishing will be required. If the test area produces a satisfactory result without removing more than 0.5 mils of clear coat, repeat the process on the entire affected area. Buff with a rotary buffer and wool pad at no more than 1800 RPM using Compound Power Cleaner or equivalent. Next, you'll want to buff the area using a rotary buffer fitted with a foam polishing pad along with swirl-free polish or equivalent. Finally, hand apply a final coat of protection using a cleaner wax. As you've seen, repairing the paint condition using non-destructive methods will keep the original paint intact and eliminate the need for refinishing and sometimes difficult color matching. Here are a few more miscellaneous non-destructive paint repair items you should be aware of. You can advise your customers on how to prevent some of these paint conditions from happening by giving them a couple of tips. One of the easiest ways for your customer to preserve the finish is to wash the vehicle often. Many types of contamination can be removed with regular washings. Apply a coat of quality wax periodically to help protect the finish from contaminants. By the way, all of the products mentioned in this video are available through Mopar. The tools used are available through Team PSE. The Daimler Chrysler Academy offers an in-depth course entitled Non-Destructive Paint Repair. The Daimler Chrysler Paint Condition Deck shown in this program is part of that course and is also available by calling 1-800-890-4038 and requesting publication number 81-170-00007. As you've seen, there are many ways the paint surface can be compromised, and repairing it without refinishing can save time, money, and increase customer satisfaction. That wraps up this month's update. Be sure to catch next month's Mastertech when we'll cover the replacement for the MDS2 called Tech Connect. Thanks for watching.